In this last video for section 13.1, we're going to do an application problem where we could actually use this in real life to figure out when a function is increasing or decreasing, right? And let's talk about it with our profit. A lot of times I want to figure out when my profit is increasing, right? If you guys are going to go into business, we want to know when our profit is increasing and maybe even if our profit is decreasing, right? So it says here, a company selling computers finds that the cost per computer decreases linearly with the number sold monthly, decreasing from 1,000 when none are sold to 800 when 1,000 are sold. Thus, the average cost function has a y-intercept of 1,000 and a slope of negative 200 per 1,000, or negative 0.2. So it is given by the formula that the average cost is 1,000 minus 0.2x, where x is the number of computers sold monthly. So now, if I want to figure out the regular cost, not the average cost function, remember average cost was when we take the cost and we divide it by however many there are. If I then multiply it by however many there are, that's going to give me my regular cost. I don't know why they don't just say the regular cost in this example, but they kind of present it a little bit tricky. So what they actually do is start out with an average cost. We then get it down to the regular cost function. So our regular cost function is 1,000x minus 0.2x squared. Then it also says, suppose that the revenue function can be approximated by this equation here. So we have cost and we have revenue. The question says, determine any intervals for which the profit function is increasing. So I need to figure out what profit function is so that I can figure out when it's increasing. If I can figure out when the derivative is positive for my profit function, that's when my profit is going to be increasing. Before we do that though, we've got to figure out what our profit equation is. It's not cost, it's not revenue. Remember, profit is really revenue minus the cost. Well, they gave us a revenue function, didn't they? That was the 0.008x cubed, yada yada, minus the cost function, which they, in a roundabout way, eventually told us what the cost function was. That was the 1,000x minus the 0.2x squared. Remember to put it in parentheses so that you can remember to distribute that negative through. When I do that and I combine my like terms, I end up getting a profit function that looks like this. Hopefully you did too. But now this is just my profit function. I want to figure out when this profit function is increasing, right? Or where its slope is positive, aka where the derivative is positive. So let's find the derivative. Let's find our critical numbers, and let's test values to figure out in which interval my profit is increasing, where my derivative of my profit is positive. Finding the derivative of this function, I ended up getting 0.0024x squared minus 4.4x plus 1,400. This is the derivative of profit. This is how my profit is changing. Remember, another word for that is marginal profit. So this is my marginal profit equation. I want to figure out where this derivative equals 0 to find my critical numbers. The problem is this gets a little bit ugly, right? At this point, this is a quadratic equation that we either need to use the quadratic formula for or use our calculator to find the zeros. I've done calculator videos already about finding the zeros. Maybe I'll do another quick one for this example specifically so we can figure out how to find the zeros. Again, you can use the quadratic formula if you'd like to, if that's easier for you. Or if you know how to use the calculator, you can use your calculator to find the zeros now at this point, because this isn't really a factorable problem anymore. I use my calculator. I got critical numbers at 409.77 and then at 1,423.66. But if you notice, I've crossed it off and I've said that it's not in the domain. If you look really carefully at the problem, these equations only work between 0 and 1,000 computers. Anything over 1,000 computers, they don't necessarily work for or are accurate for. So because this is 1,400, it's out of my domain. So I can only use this critical number in the problem, 409.77. That's where my derivative equals 0. Now, does it equal 0? Does my derivative equal 0 and go like this? Or does my derivative equal 0 and go like that? Well, if my derivative equals 0, at 409.77. It's got to either be positive or negative before, and it's got to either be positive or negative after. So let's test a number before 409 and after 409 in my derivative to see if my derivative is positive or negative. I tested 0. I made sure that 0 was in the domain, which it is. It says equal to 0. So I tested 0 because that was the easiest for me to test in this funky derivative, remember, right? We're testing it in the derivative. I'll even show you, well, I'll wait for that for next time. But I'm going to test it a 0 in my derivative. I ended up getting a positive number, positive 1400. I also tested 500 in my derivative, and I ended up getting a negative number in my derivative. If my derivative is positive, then I know my profit is increasing. So my profit is increasing starting at 0 and going to 409.8. I know that my profit is decreasing, going down from 409.8 to 1,000. So if this is my company, I want to know when my profit is going up, and then I also want to know when my profit is going down, because I'm going to hit that maximum profit if it's going up, but then as soon as it goes down. Isn't this a maximum value here? So I know that I'm going to hit my maximum profit when I sell about 409 computers. So that's the goal that I want for my company. I want to maximize my profit. Before I can figure out where that maximum is, I've got to figure out where my function increases and then where it decreases so I can find that point. All by using my derivative. Make sure you practice a few of those so you can kind of do an application problem for increasing and decreasing.